Welcome, students. Today we're going to talk about formulas. Now, we've spent the past few classes solving equations. Each of the equations that we've looked at and solved so far has only had one variable, like x or y. But in the real world, the formulas we deal with have several variables. We're going to look at some examples today, and we're going to look at how to solve a formula for a particular variable. For our first example, we'll take a look at a relationship that you might see if you go shopping. Now, I imagine most of you like to go shopping when things are on sale. We all like to save money. And so if you go to a store and something's on sale, usually there is a list price, which is the original price. But you don't pay the list price because it's been reduced by a certain amount, which we'll call the discount. And once the price has been reduced by that much, we end up with the new sale price. So this is a relationship between the original price, or the list price, the amount that it's been reduced, which we call the discount, and then the sale price, which is the less expensive price that you pay for. So we don't want to have to write out an equation that has words in it. So we'll represent each of these with a variable, and it makes sense to use L for list price, D for discount, and S for sale. So the relationship that we have is list price minus discount equals sale, and this is expressed as an equation or as a formula. We generally use the word formula to represent an equation with several variables that's generally always going to be true, right? Every time we go shopping, if something is on sale, you can take the list price and you can subtract that discount to get the sale price. If you've got a $5 off coupon, then the list price minus $5 gives you the sale price, for example. All right? So this is one way to write the relationship, and if I gave you the list price and the discount, you could take the difference to calculate the sale price. But sometimes we might be given the sale price and the list price, and we want to figure out what the discount is, and we need to figure out how that works. Well, what we can do here is we can solve for D. We can solve for the discount, but in this situation, we won't get an answer like D equals 3. We will figure out what D is in terms of L and S. We can use the same properties that we used before. We can add or subtract the same quantity from either side. We can multiply or divide both sides by the same non-zero quantity. We can combine like terms. We can use the distributive property. The same rules work. It's just a little bit more complicated because we have multiple variables. So what I want to do is show you how this works. For this particular example, I want us to solve the equation L minus D equals S for D. That means we want to isolate D on one side of the equation. Right now, D is on the left-hand side of the equation, and there's another term there. There's an L on the left. What we want to do is we want to get rid of that L because that will help us get closer to getting the variable D by itself. So what I'm going to do is I'm going to subtract L from both sides to get rid of that L term. When I do that, we're left with the opposite of D on the left, that negative D. And then on the right, we have S minus L. We can't actually do the subtraction because we don't know what S and L are. They're not like terms, so to represent S minus L, we just have to write S minus L. Now, we almost have D alone, except what we have here is a negative sign in front. Now, if I asked you what the coefficient on D was, hopefully you could tell me that it's negative 1. There is an invisible 1 there. This is the same as negative 1D equals S minus L. So if we want to get D alone, right now D is being multiplied by negative 1, and the opposite of that is dividing by negative 1. So we need to divide both sides by negative 1, and to do that we have to take each term on the right and divide them by negative 1. All right, So on the left-hand side, when we do this division, we're left with d because the negative ones cancel. On the right, s divided by negative 1 is going to be negative s. And then the next term, we've got a negative divided by a negative, which gives us a positive, so it's going to be plus L. Now this is a fine answer, but it's going to look a little bit nicer if we swap the order of the terms on the right, putting the L first and that minus S afterwards. It's just a slightly nicer looking formula. We have D equals L minus S. So here, if we want to know the discount, and we're told the list price and the sale price, this formula tells us we can take the list price minus the sale price, and that gives us the discount. Solving a formula for a variable allows us to write the relationship in a different way, but with that particular variable isolated, so that we can figure out what its value is in terms of the others. Let's take a look at a couple more examples. Let's solve P equals 2L plus 2W for L. You might recognize this as the formula for the perimeter of a rectangle. The perimeter equals twice the length plus twice the width. This tells us how to figure out the perimeter if we know the length and the width. But let's suppose we want to figure out the length if we know the perimeter and the width. To do that, we're going to want to get L by itself. We're going to want to solve for L. So let's get L alone. We've got this 2L term on the right. There's also the 2W term. We're going to want to get rid of that. So we're going to subtract 2W from both sides. If we do that, this leaves us with P minus 2W on the left. And on the right, it gives us 2L. Now, if we want to get L alone, we have to get rid of this 2. And because L is being multiplied by 2, to get rid of it, we divide both sides by 2. There's actually two different ways of doing this, and so I'm going to write both of those out. We could take each term and divide it by 2, or we could take the whole left-hand side and put it all over 2. Both of these are acceptable ways of doing it. Let's try both ways and see what we get for an answer. I'm going to do the first way first. P divided by 2 is just going to be the fraction P over 2. Then minus, if we take 2W and divide it by 2, that gives us 1W, or just W. So we have P over 2 minus W on the left. On the right, the 2's cancel out, and we're left with L. And so when we solve this for L, we can see that L is equal to P over 2 minus W. Now, the other way I did it is equally valid. On the left-hand side, we're just left with the fraction P minus 2W over 2. And then on the right-hand side, the 2's cancel, and we're left with L. And this is also an acceptable answer. Both of these are fine. If you enter them into WebAssign, it's going to mark them as correct either way. I just want to point this out because sometimes two students will get answers that look different but are equivalent. So it's possible that you might disagree with someone and both of you have correct versions of the answer. Just an important thing to notice. There are several more videos of worked out example problems if you click on the link below, and I want you to go through at least a few of them because they use different techniques than these. We saw in these problems, in the first problem we needed to subtract something from both sides. Here we needed to subtract something from both sides. You will find examples where you need to add something on both sides. You'll find examples where you need to multiply to get rid of denominators, to get rid of fractions. You might find examples where you have to distribute. So there's a whole bunch of things you might need to do, and the only way you're going to get really comfortable with all of these is to look through those problems and get practice.